Welcome everyone to this lesson on PCBs. So if you're not already aware, PCB stands for printed circuit board, and in the internals of our router, that is this green board here. Now you hear PCB used interchangeably to reference both just the bare board, so that is just this green portion of the board, and then also what is called the PCB assembly, which is actually the bare board, then with all of the components that are soldered and attached to the board. So generally, when people are talking about PCB, they'll use it interchangeably and they'll just call it the board or PCB. And most frequently, that will refer to the actual whole board itself, including all of the components on it. I'm going to move our target router to the side here and show you an example of just a bare board so that we can look at some of the features of it. So this is called a helping hand. It's just good for holding electronics in place. I'm going to use it just to hold this board a little bit closer to the camera. All right, so the PCB has two main functions. The first one is that it holds all of the components in place, and it does that by we have these items here. So here and here and here, and there's many of them on the board, and these are called pads. And the components like the resistors and the chips all get soldered to these pads, and that helps hold them in place. So on this PCB, we actually have two different types of pads. The first one is example is right here, and these are called through hole. And the reason for that is these are actually a hole on the board that have a metal ring of conductive material, and the components actually go through this hole and then are soldered in place. So you can see, I don't know if you can see, I can actually poke through it here. The second type of pad that we have are these, an example right here. So we have many of these ones as well. And there's no hole here. We just have a metal rectangle of conductive material. And the components don't have any leads. They just get soldered directly onto these pads. And that's called a surface mount pad because the components are directly surface mounted on there. So I'll just flash up on the screen here quickly to show you an example. On the left here, I have an example of a through-hole resistor. These metal wires on the sides of it here are called the leads. And you can see here an example of it on the board. So the leads will actually fold. These would be holes that they would slot through. So you can see some examples of those holes right here. You push the leads through the holes and then they get soldered in place. That's why it's called through-hole. And then on the right-hand side, this is an example of a surface mount resistor. Instead of leads, we just have these metal edges that are on the sides of it. You can see here on the board, they actually just fit onto those pads that we were showing, and they get soldered into place that way, and there's no holes or anything. In commercial boards these days, you're going to be much more likely to see mostly surface mount components, and there's many reasons for that. One, they can be made much, much, much smaller. You will see that on the actual router board. And then second, it's much easier to automate the process of creating these boards. We can have machines much more easily drop these into place instead of having to bend the leads and push them through the holes. And we'll take a closer look on our target PCB of the router as well at how those look. The second function of the PCB is that it actually electrically connects all of the components together to form the actual circuit. And the way that it does that is with these green lines that you can see drawn on here. So these are what are called traces, and they are electrically conductive, and they perform the function of wires on the PCB. For us as hardware hackers, this is quite important because we can actually start to visually inspect the PCB and try and figure out what the circuit is doing and where the signals are routing on the actual PCB. One thing that does make this tricky though is that modern PCBs now have many layers to them. So of course with these traces, for example, like these ones, we're not actually able to route through them. So if we wanted to cross through here, for example, we cannot route through these traces. So what we have done in modern PCBs is we actually make them multi-layer. And that way we can have traces buried in the middle of the PCB, and we can also have traces and components on the back. So I'm just going to quickly flip this one over to show you how that looks. Okay, so looking at the back of this PCB, you can see that we actually have some traces that are just visible on the back that are connecting some of our pads. And we also, for example, here, this F1, this is a fuse, so we can see that it actually is only on the back as well. And then the last thing that I want to show here that is really important and unfortunately makes our lives kind of tricky as reverse engineers is we can see that we have this D1 here, so diode 1. And you can just make out the traces here, but they don't seem to go anywhere. They just go to these very tiny metal holes that are not actually through hole pads. And if I just flip the PCB back over, so if you just keep in mind where this is on the PCB, so when I flip it over, can see now this is where that was, and there's no traces or signs of anything, and we only just have these two metal holes here. So what these are called is they're called vias. And vias we can think of as traces that go between the layers. So they actually take the trace and then they transport that electrical signal. So these have conductivity and then they go to layers. So on this PCB, that diode's traces, they actually go up and only into the middle layer of this, which we're not able to see. So that does make it a little bit more challenging for us to reverse engineer. However, there are ways that we can get away from this. So just to demonstrate what the vias look like, I'm going to pop up on the screen here a quick image and chat about them briefly so you can see in 3D what they look like. On the left here, I have a sample PCB where we can see in the top we've got the assembly, and then on the bottom, just to show what it would look like without the components soldered on, we can see just the bare board with the pads. Now on this board, we have some vias as well, so we've got a few vias here, and you can see what those look like on the bare board. So what this would look like if we just do a break apart of this into kind of a 3D look. I've done a drawing. These aren't actually like all of the traces that you'd see on this PCB, but just to give you an idea, the vias run down between the traces. So there's an actual like metal connection, like metal pipe, you can also almost think of it. And it brings those connections from one layer down to the other, and then we can route these circuits. So this one I've drawn with 3, but we can get many, many more layers in actual production PCBs. Okay, so we're back here with the target router PCB, and I'm just going to lift it out of this bottom part of the enclosure. So it can just lift right out. There's nothing that's actually holding it in. It's just resting on a couple of pegs here. All right, so I'm just going to lift it out. And then the only thing that's actually attaching it is these wires, which go to the antennas. So if we're just gentle, we can lift it out, though, to work on it. And what I'm going to do is I'm just going to quickly put it on the helping hand so that we can get a closer look at the PCB itself. So unfortunately, our target PCB is a little bit more complex than the one we were just looking at. But in case you're getting intimidated by taking a look at this, do not worry. We don't actually need to know everything about this or how it works. There's just a few key points that we're going to start taking a look at and learning to identify that are going to help us along our journey with hardware hacking. Now, the couple things I just wanted to show here are we're on this board, we are mostly surface mount components, and they are so tiny on this board that it is actually very hard to even see some of them. Even on this 1080p camera, it's hard to get them in focus. Of course, so we've got our chips here, and they are surface mount. They just rest on top. And then they're very hard to see, but all of these little items here are actually components. So we've got capacitors, resistors, all tucked in there in their little surface mount packages. Here's a couple that are bigger, and it's really, really hard to show these because they're so small. Just put my finger in for reference so you can see. Like, I could fit almost all of them on the tip of my finger here. Now we do have a couple through hole components. So we've got these LEDs here that are through hole, and then our capacitor that's through hole. And generally things like, your push buttons and these Ethernet ports are also through hole. And the reason for that is one of the advantages of through hole components is they actually hold things in place much better. So for bigger items that might be able to get bumped, or we're going to be plugging them in and out, you'll usually see through hole used. And I'll just quickly flip the board over so you can see what that looks like on the back. So you can see on the back of this is actually where these components, their leads stick through, and they are actually soldered through those through holes. that wraps up this first look at PCBs. I'll see you over in the next lesson where we're going to break out our multimeter and start doing some testing on our PCB.